Good day, my angels. Here are the solutions to Lesson 2, Joule's Law. Number 1. So it says a 120 volt source, probably a power outlet, is connected to a 300 watt resistor. Now, resistors are measured in ohms, but I guess this resistor with this appliance, whatever it is using 300 watts of power. So find the current. Okay, well, I know that the voltage is 120. I know that power is 300. And the two equations I'm going to be flogging to death are Joule's law, which we did in this lesson. Power equals I times V, or V times I. I think on your formula sheet I wrote it V times I. And Ohm's law, which says that voltage equals I times R. And I think I said to you, if I know two things, I know four things. So first of all, it wants the current. I'm pretty sure current is going to be power divided by voltage. It's going to be 120 divided by 300. So it's going to be 120 divided by 300. And I get, oh, did I write that right, Mr. Dueck? Did that exactly backwards, Mr. Dueck. 300 divided by 120. Should I restart the video? No, I make dumb mistakes. I'll leave this in the video. How about 2.5 amps? I guess that also means, by the way, another unit for current is watts per volt. Okay. B, the resistance. Well, R equals V over I. So V was 120. I just calculated to be 2.5 amps. So it's going to be 120 divided by 2.5, 48 ohms. C, how much energy? Well, remember, power is also work or energy over time. So energy is going to be power times time. This is how BC Hydro calculates people's hydro bills. The only issue is this gives us an answer in joules. Typically, BC Hydro charges you in kilowatt hours, but it's going to be power, 300, times time. Well, it's 20 minutes, so 20 minutes times 60 seconds. 300 times 20 times 60, and I get 360,000 joules, 3.6 times 10 to the 5th joules. If I want it in kilowatt hours, I divide this by 3.6 times 10 to the 6th. That's the conversion factor. Again, you don't need to memorize the conversion factor. I'll give it to you if I ask it. It's about 0.1 of a kilowatt hour. Number 2. Boy, I miss teaching all of you. Okay, they want the current. Again, they've given me the power, 1500 watts. The more heat an appliance is moving around, the more watts it's going to use. So a kettle is going to be typically a fairly high wattage appliance. Voltage is 120. So again, current is power divided by voltage. It's going to be 1500 divided by 120. And 12.5 amps. What that also means, because a standard outlet can only handle 15 amps, if you tried plugging two of these kettles into the same outlet, you'd blow the breaker. So if you've ever blown a breaker before, it's because you were asking too many amps from that outlet. The resistance, R equals V over I. It's going to be 120 divided by 12.5. Dope. 9.6 ohms. C, the energy in kilowatt hours used in a day. So I'm going to assume 24 hours. Energy is power times time. So it's going to, oh, again, I got that by recognizing that power is work or energy over time. So energy is power times time. The power is 1500. The time is 24 hours times 60 minutes times 60 seconds. And I get that many joules, 1.296 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Only this wanted it in kilowatt hours. So to change this to kilowatt hours, it's going to be 1.296 times 10 to the 8th divided by 3.6 times 10 to the 6th. And I get 36 kilowatt hours. How much money would that be? So price is going to be 36 kilowatt hours times, how much is it per kilowatt hour? 5.2 cents, so 0.052 times 0.052, and I get $1.87. Number 3. A 220 watt computer is connected to 110 volts of alternating current and left on all month. Find the resistance. Okay. Well, I also know that power equals V squared over R. So if I want to go straight to finding the resistance, I guess R is going to be V squared over power. It's going to be 110 squared over 220. 110 squared over 220. And I get 55 ohms. I could also have done what I did in the previous question, which is find the current and then find the resistance. Oh, B wants me to find the current anyways, so current is power divided by voltage, or I could go current is voltage divided by resistance, because now that I know resistance, if I know two things, I know all four things. But I'll use power, 220 divided by 110. I think I can do that in my head. I'm pretty sure it's exactly 2 amps. Find the energy used in a 30-day month. Okay. I'm probably going to convert this to kilowatt hours because part D is asking for an answer for a price using kilowatt hours. So energy is power times time. It's going to be 220 times 30 days times 24 hours times 60 minutes times 60 seconds, and then to change it to kilowatt hours, divided by 3.6 times 10 to the 6th joules per kilowatt hour. I will put the units in. I'll get 220 times 30 times 24 times, I'm going to be lazy and go 60 squared, divided by 3.6 times 10 to the times 10 to the 6th, and I get 158.4 kilowatt hours of energy. 158.4 kilowatt hours of energy. D. If it's 5.5 cents per kilowatt hour, then the price is going to be 158.4 times 5.5 cents, but let's convert it to dollars. This would cost $8.71 to run all month. So now it's starting to add up a little bit. I think I went on a rant during the lesson about why do we shut stuff off? Electricity is too cheap. We shut stuff off to save the environment, which is true. But okay, this does also start to add up. So don't leave your computers on. Although, or at least activate the sleep mode, which reduces power pretty dramatically. Next question, number 4. Takes 10 kilojoules of energy to cook a hot dog. If a 30 ohm dog is connected to 120 volts, how long will it take until it is cooked? Okay, they want me to find time. I have energy, it's 10,000 joules, 10 kilojoules. I have resistance, 30 ohms. I have voltage, 120. What can I do with that? Well, I know that power is energy over time. So time is going to be energy divided by power. And I know that power is V squared over R. Got it. So it's going to be 10,000 divided by, and since I got a fraction in the bottom, I will have to put the fraction in the bottom in brackets. 120 squared divided by 30. 10,000 divided by bracket 120 squared over 30, close off the bottom, and I get 20.8 seconds. Believe it or not, this is sort of how they figure out the times on microwave oven instructions. So if you're making something in the microwave and you're reading the package instructions and it tells you how long to microwave the object for, they know approximately how many joules of energy it takes to cook it. They know the wattage of an average microwave oven, but they always do say microwave oven times may vary because there's smaller ovens and bigger ovens, and the smaller microwave ovens have a lower wattage, the bigger microwave ovens have a larger wattage. But that's how they figure it out. It's going to be seconds. I don't know how many of you actually watch these, but I'll give you a little by the way. A really cool website to look at. Do a Google search for unwise microwave oven experiments. This is a website, I think it's run by a prof at the University of Washington, but I also need to do the old reliable don't try the experiments yourself at home. But there's some really neat stuff you can do with a microwave oven. So what he does is he just scours garage sales for old microwaves that he can get for like $10 or $5, and then he experiments on them, usually until they break. So that's the other reason you don't want to use your parents' microwave for this. Number 5. So there was a typo in the assignment that I sent out. The question part of number 5 never showed up, just the multiple choice answers. So the question that should have showed up, and now I've fixed it, is which of the following is the best definition of current? Well, current is Q over T. That's from your formula sheet. So number of charges stored in a cell? No, that would be Q, coulombs. Amount of energy in a charged object? No, current is not energy. Charge passing a point in a given... C it is. Number 6. Again, we're exploring our theme is if I know 2 things, I know 4 things. Oh, this one also gave me coulombs. Oh, wait a minute. It gave me coulombs and it gave me seconds. It gave me the current. So what do they want me to find? First of all, what current flows through the bulb? Current is Q over T. So it's going to be 45 divided by 5. I could do that in my head. 9.0 amps. This is a bad question just because I was making up numbers. Light bulbs don't use 9 amps. Otherwise, you would only be able to run 1 light bulb off of a circuit at a time because 2 light bulbs would require 18 amps and blow your breaker. I was making up nice numbers, but I wasn't making up realistic numbers. Sorry about that. B. What's the resistance? Well, R equals V over I, because V equals I times R. So it's going to be 12 divided by 9. I can do that in my head too. It's going to be 1.3 repeating ohms, I'm pretty sure. And then C, power equals V times I. It's going to be 12 times 9. I can do that in my head as well. This is a 108 watt bulb. The light bulb, a 100 watt light bulb is okay, but I got the I started with the resistance and I worked my way backwards. I've got the wrong resistance for this light bulb. I'm willing to bet the resistance is much higher, which makes the current much smaller. And yeah, you know what? The resistance for an incandescent bulb would be high because they get white hot and they give off lots of heat. And the reason that is there's a high resistance. And so electrons are making, sorry, we're pretending it's not the electrons. We're pretending it's the protons that are moving. The protons are smashing into other charges, giving off their heat as they move through. I wonder how many of you are actually watching this. A battery, a 6-volt battery, probably a golf cart battery, transfers 24 coulombs of charge through a light bulb in 16 seconds. What current flows through the circuit? Okay. Again, current is Q over T. I see 24 coulombs. I see 16 seconds. Can I do that in my head? Yeah, divide by 8, divide by 8. Oh, it's going to be 1.5, I'm pretty sure. Of course, I got the answer sitting in front of me. Why am I doing this in my head? Just to check my answer key, make sure I didn't make a silly mistake. B, what's the resistance of the light bulb? R equals V over I. It's going to be 6 volts divided by 1.5. Can I do that one in my head? Well, 60 divided by 15 is 4, so 6 divided by 1.5 is going to be 4 as well. My ohms symbol gets messier and messier. Let me make that a little better. And C, power. Well, power equals V times I. So it's going to be 6 times 1.5, which I'm pretty sure is 9 watts. Number 8. An electric motor with a constant power source, constant resistance. I said constant resistance because electric motors can heat up, and when they heat up, the resistance actually changes, so we're ignoring that. Draws 0.6 amps, 4.8 volts. Motor is now, oh, this is going to be a before and after, I think. So here is going to be the 4.8 volt source. Here is going to be the 9.0 volt source. I think what I'm going to do is I'm going to find the resistance of the motor here, and it's going to be the same resistance over here. And that way I'll be able to solve this. I'm going to start with what I do know. It's going to be V over I, which is 4.8 over 0.6. So that should work out evenly, I think. Should work out to 8, I think. Yes? Yeah. So the resistance of this object is 8 ohms, and now I'm going to move that to this side. The new current and the new power used. So I still have V equals 9.0 volts, but I also know that, hey, if I know 2 things, I can find all 4 things. Current is going to be V over R, which is going to be 9 divided by 8. 1.125, yep. Oop. 1.125 amps. And power is, I could either go V squared over R, or I could go V times I, or you know what, I'm going to go V times I. And that's going to be 9 times 1.125. Power is going to be 10.1 watts. Number 9. Mr. Dueck, this is getting kind of repetitive. I kind of hope so. We're going to get into solving circuits next class. But to solve circuits, V equals I times R and P equals V times I, they kind of have to be at your fingertips. It's a little nice if you can sort of do those almost in your sleep. So, A, how much power will this use? Power equals V squared over R. It's going to be 120 squared over 25. 576 watts of power. What must be the resistance of another heater to produce the same power output when connected to a 240 watt supply? Okay, so R is going to be V squared over power, but this time we want the same power output, 576 watts of heat per second, joules of energy per second. But here it's going to be 240 squared. Europe mostly uses 240 volts through their power outlets. It's why you have to buy an adapter if you travel in Europe. There are pros and cons to both systems. Answer B. Did I not put an answer for B? Oh, I'll have to add that to mine. I'm getting 100 ohms. Which makes sense. Twice the voltage, but there's a squared 4 times the resistance. Number 10. A 24 volt supply is connected to a 15 ohm resistor. Forgot the word resistor. For 3 minutes. How many coulombs of charge? Oh, okay. Now they want charge. Well, I know that current is charge over time, so I guess charge is going to be IT. But they didn't give me current. Charge is going to be V over R times T. The voltage is 24. The resistance is 15. And the time is 180 seconds. I did that in my head. And I get 288 coulombs of charge. Number 11. Which of the following has the greatest rate of energy consumption? Okay. Well, for all of these, power equals V times I. So if I quickly crunch this, let's see, Mr. Dueck. 6 times 0.2, I could have done that in my head. This is 1.2 watts. By the way, the rate of energy consumption, that's another word for power, because power is how fast you're using up energy, joules per second. 4.5 times 0.5 should be 2.25, I think. Smartphone, 3 times 0.6, 1.8 watts. 120 times 0.025, 3 watts. And the answer is the fan. Is that the last question? Yes, it was. Again, I'll also be emailing out a Whoa Wednesday. It'll be 4 different YouTube channels. And as always, I miss all of you, and I hope you're being safe. I hope you're doing well. Again, if you have any questions or any challenges in doing this, please let me know. The most important thing right now is that you are doing well.